Bismillahirrahmanirrahim. Assalamu alaikum everyone. Today we are going to discuss RSA algorithm in cryptography. Basically, RSA algorithm is used in asymmetric key cryptography in which two keys are used to encrypt and decrypt the data. The first one is called private key and is denoted by E, and the other one is called public key, which is denoted by D in the whole algorithm. If private key is used to encrypt the data, then public key is used to decrypt the data. It means that you are not going to use the same key for both encryption and decryption of the data. If you are using private key for the encryption, then there must be the need of public key for the decryption of the data. Similarly, if you are using public key for the encryption, then there must be the need of private key for the decryption of the data. Point here to be noted is that mostly private key is used to encrypt the data and the public key is used to decrypt the data. So we are going to use private key for the encryption purpose and the public key for the decryption purpose in the whole algorithm. Then these are the steps that are used in RSA algorithm. First of all, you need to take two random and large prime numbers denoted by P and Q, large prime numbers. Then you have to calculate n, which is equal to the product of P and Q, the large prime numbers. Then you need to calculate the phi of n, which is the product of P minus 1 and Q minus 1. Then after calculating phi of n, you need to choose the private key such that the private key must be greater than 1 and the less than phi of n. Also keep in mind that private key should also be a prime number and its value must be close to P and Q. Another point here to be noted is that E and phi of n must be co-prime. It means that the GCD, that the greatest common divisor of E and phi of n must be equal to 1. Okay, then we need to calculate public key such that the product of public and private key and their mod with phi of n must be equal to 1. We are given with whole prime numbers and then we need to calculate n, then phi of n, then we can choose private key of our choice. But from all these values we need to calculate D by our own. So here's the formula for computing D. The product of public and private key and their mod with phi of n must be equal to 1. D must be the digit of which if we take product it's with E and calculate mod of their product with phi of n, its answer must be equal to 1. This can be understood with the example given below. Let's suppose you are given with the private key E equal to 3 and the phi of n of the values P minus 1 and Q minus 1 is equal to 20. Then you need to calculate D such that D multiplied by 3 mod of 20 should be equal to 1. The computing D with this formula will be catastrophic because it is not easy to guess the right value of D, of which if we take the product with E and calculate mod of phi of n, its answer must be equal to 1. So I am giving you the solution for computing D in an easy manner. This is the formula for the easy computation of public key. D equal to 1 plus k multiplied by phi of n divided by E, where k equal to 0, 1, 2, 3 up to so on, and we can simply call it as a iteration number. Remember that always start with the value k equal to 0 and then compute D accordingly. The stopping criteria is that at the point where you find the first whole value, that will be your public key and you need to stop computing the value of D at that point. For example, you are given with the private key which is 3 and the phi of n you are given with is 20. When you need to calculate the public key, at first you need to put the value of k equal to 0 and then compute D. By putting the value of k 0 and after the computation we are getting the answer 1 by 3 which is 0.33. At this point you need to ignore the values in points, so 0.333 value is ignored. Then it means that you have to take the whole value as your public key. At the first point where you find your first whole value, that will be your public key. Then we will shift to next iteration for k equal to 1. Now in the formula we have put k equal to 1 and computed the value of D which is equal to 7. Now 7 is the whole value. You need to stop computing the value of D right here because you have got the value in the whole number in this iteration. So your public key is equals to 7 in this scenario. Now let's get the idea of the working of RSA algorithm through an example. Your public key is denoted by D, N. Your private key is denoted by E, N, and the encryption formula in the RSA algorithm is C equal to P raised to the power E mod of n, and the decryption formula is P equal to C raised to the power D mod of n, where C is your ciphertext, P is your plaintext, and n equal to product of P and Q, the large numbers, prime numbers. So let P equal to 3 and Q equal to 11. In this example, we cannot take values of P and Q too large because the computation will be catastrophic, and so we are just getting an idea how to implement RSA algorithm with the small prime numbers P equal to 3 and Q equal to 11. So the n will be P cross Q equal to 3 multiplied by 11 equal to 33. Your n will be 33. Your phi of n will be 20 because 3 minus 1 equal to 2 and 11 minus 1 equal to 10, and their product is 20. Let your private key equal to 7. You can choose any private key of your choice, but keep in mind that the value of private key must be close to P and Q, and also E must be a prime number. Then you need to check whether the GCD of E and phi of n equal to 1 or not. You have to take the value of E such that it will be co-prime with the phi of n. So 7 and 20, its greatest common divisor is 1. We can take the value of private key equal to 7. So let's compute the value of public key now. You can use the formula either of your choice, whether you are easy with the first one or the second one. I am going to use the second one. Let's compute the value of D now. So always start with k equal to 0 and put it in the formula, which is highlighted in the red. So after putting k equal to 0, we are getting the answer 0.142, which is the decimal value, not a whole number, so we have to ignore the value. And let's shift to the next iteration. For k equal to 1, then we are getting the value of D equal to 3 after the computation. So this is the whole value. You need to stop computation right here, and your public key will be 3. Let's encrypt our given plain text, which is itself a text, text text. Check the position of the plain text in the alphabet. So the position of T is 20, the position of E in the alphabet is 5, position of X is 24, and the position of T again is 20. So converting this plain text into ciphertext by the formula C equal to P raised to the power E mod of n, where n is the product of P cross Q, which we have calculated before, and is 33. P is the position of the plain text in the alphabet and E is your private key, which is 7. So C1 is the first ciphertext for the given plain text T. So we have calculated 20 raised to the power 7 mod of 33, and the answer in the ciphertext is 26 mod of 33. This is the simple method from which I have calculated the value in the range of mod of 33 because the value of 20 raised to the power 7 is a huge number. First, just compute the value 20 raised to the power 7, which is 128000000, and it is not in the range of 33. How can we take it into the range of 33? Simply divide the calculated value 128000000 with 33 and get the value, which is 38,787,878.787878. Just ignore the value after the points and take the value before the point and multiply it with the 33. The answer is 127,999,974, and simply subtract the value from the original value 128000000, and you will get the value in the range of mod of 33. Again for C2 I have done the same thing because 5 raised to the power 7 is a value which is not in the range of 33, so I have calculated the value in the range of mod of 33 in the same manner which we have calculated before. And the ciphertext for plain text E is 14, and the ciphertext for plain text X is 18, and the ciphertext for plain text is again 26, mod of 33. So our final cipher text in the number form is 26, 14, 18 and 26, and in the alphabetic form it is Z, N, R, Z, because 26 position is of Z in the alphabet and 14 position is of N in the alphabet, and similarly position 18 is denoted by R in the alphabetic form, and position 26 again is denoted by Z in the alphabetic form. So this is all from today. Thank you for watching this video.